Thank you. Okay, so now that you have everything canceled out that could possibly be canceled out, you have -1 times 8, which is -8 times 3x minus 1 all over x plus 8. Okay, now remember, you can't cancel out the 8's here because of that plus sign. If it was x times 8, you could cancel it out. But because that plus sign is in, you have more than just factors. You can only cancel out when you have just multiplication. Okay, so that would be your final answer. Yes?
You wouldn't distribute the -1 to the rest of the denominator?
Well, with multiplication, it's kind of like, oh, let me get a quick example. So if you did have, let's say, -1 times 2 times 3, you can either do -1 times 2, or you can do the -1 times 3.
Okay.
So if you were adding them, then you'd have to distribute it to both.
Okay.
So if you had like -1 times the 3x minus 1, you could have distributed to both of those. But I just combined it with the 8, just to make it simpler. Does that make sense?
Mm-hmm.
Okay. Okay. Any questions? Any other questions? All right. So they're not the shortest of problems, but if you kind of keep each step. Oh, let me move that back up in case anyone's still writing. Each individual step hopefully is not horribly confusing. All right. Okay. Okay, so now we're going to divide our rational expressions. Okay. And this is really just multiplying the rational expressions, but you're doing the old trick when you're dividing fractions. Okay. So if you remember, P divided by Q divided by S. Your steps for dividing fraction is you write down the first fraction. Change your division to multiplication. And then you flip the second fraction. Okay, so those are your steps for dividing fractions. Okay, so that means this will become, you write down your first fraction, change your division to multiplication, and then you flip the second one. Okay, so that just becomes P times S over Q times R. Oops. All right, so if you had that in just a basic fraction, so let's say, for example, if you have 5 over 3 divided by, let's say, 7/5. Okay, so you'd write down the first fraction. It's okay, let me rewrite that real quick. Okay, so your first step, just be writing down the first fraction. Change your division to multiplication. And then you flip the second fraction. So once you do that, then you just multiply like we did before. So you have 5 times 5. Oh, let me write out the whole thing. Over 3 times 7. Which just becomes 25 over 21. Okay. So we're doing the exact same steps, but we have to do our factoring and everything else with rational numbers. But other than that, the steps as far as dividing, exactly the same. Okay. Okay, so the steps for dividing rational expressions. Okay, so your first step is you're going to write the first expression. Or your first fraction. Second step, you're going to change division to multiplication. Then you're going to flip the second fraction. And then after that, you're just going to go through the steps that we went over before for multiplying. Then now you can just multiply. Whoops. Clean that up a little bit. All right. Let's say, for example, if we wanted to divide x plus 2 squared over 10 divided by 2x plus 4 over 5. Okay, so the first thing we want to do is get rid of that division sign. Okay, let me just rewrite it. Okay, so remember your first step. Write down your first fraction. X plus 2 squared over 10. In your second step, you're going to change your division to multiplication. Then your third step, you're going to flip the second fraction. So now you have 5 over 2x plus 4. Okay. So now your fourth step would just be to multiply like we did before. Okay. So x plus 2 squared over 10 times 5 over 2x plus 4. Okay, so we'll do all of our factoring work on the side. So x plus 2 squared, you can just write that as x plus 2 times x plus 2. Okay, so that just becomes x plus 2 times x plus 2. And 10, you can just make that 5 times 2, because this way you know you'll be able to get rid of that 5 up there. Okay, so over 5 times 2. That 5 is just 5, so you don't have to do much with that one. And 2x plus 4. You can actually factor a 2 out of both of those. So that's 2 times x plus 2. Okay. So if you wanted to, you could cancel the 5s here and the x plus 2s here, but like I said, just my own little personal quirk. I like to have everything as one fraction, so we just multiply it across. X plus 2 times x plus 2 times 5 all over 5 times 2 times 2 times x plus 2. Okay, now we can start canceling out, because this cancels out with this one. This 5 cancels out with this 5. And nothing else cancels out. So you have x plus 2 up here. Everything else is gone. Over 2 times 2 is 4, so that just stays 4. Okay, and that would be your final answer. You don't really need the parentheses up top. I just kind of put it there out of habit. Any questions on that one? All right, so let's do another example here. All right, so okay. Okay, so now we're just going to add and subtract our rational expressions. Okay, and just like any fraction, you're going to have to deal with the like denominators and the unlike denominators. Okay, so we're going to start with the like denominators. Okay, so remember, if you go back to just your regular fractions, if you have P over Q plus R over Q, if you have the same denominator, then your answer is going to be over that same denominator. And then you just either add or subtract your numerator. Okay, so if we put that in just regular everyday numbers, if you have, let's say, 5/8 plus 2/8. If the denominators are the same, then your answer is going to be over that same denominator. Your numerator, you just add those together. Or you subtract depending on what you have up there. Okay, so you just end up with 7 over 8. Okay, that's the one thing you want to remember about multiplying and adding and subtracting, is that when you multiply, you just multiply right across. When you're adding or subtracting, the denominators have to be the same, and you don't add the denominators together. So the same rules apply for rational numbers. The only difference is you're dealing with factors and polynomials and all that other stuff. Okay, so let's say, for example, if you wanted to add x over 9 plus 3x over 9. Okay, so the first thing you notice, the denominators are the same. All I have to do is add or subtract my numerator. Okay, so if you have x over 9 plus 3x over 9, you automatically know that's going to equal something over 9. Okay, we just have to add our numerators. X plus 3x. Okay, which ends up being 4x over 9. All right, so what if we have, say, for example, if you wanted to add, say, 4t minus 9 over 9t plus 7 over 9t. Okay, that one's the exact same way. If you have 4t minus 9 over 9t plus 7 over 9t, you automatically know that number is going to be something over 9t. Okay, so that means you have 4t minus 9 plus 7. So you have 4t minus 9 plus 7 over 9t. You can combine those two. Negative 9 plus 7 is just negative 2. So you end up with 4t minus 2 over 9t. So any questions on that one? Okay. I'll leave that up for a second. All right. Got time. Okay, so let's say, for example, on this one, if you want to subtract x squared plus 10x over x plus 3 minus 4x minus 9 over x plus 3. Now with subtraction problems, you have to remember you're subtracting the entire second numerator. So x squared plus 10x over x plus 3 minus 4x minus 9 over x plus 3 actually becomes, well, I can put it up here. you automatically know it's going to be something over x plus 3. Okay, just because the denominators are the same. But here you end up with x squared plus 10x minus that entire second fraction. So minus 4x minus 9. Okay. So that's going to equal clean that up, x squared plus 10x. If you distribute that negative 1, minus 4x plus 9 over x plus 3. Okay, so the one mistake you don't want to make, or you want to be conscious of, is not just having minus 4x minus 9, because then you're just multiplying that term by negative, when you should be